So while you're finding where we left off yesterday in your notes, okay, this is where we left off. We were practicing writing the names for chemical compounds involving multivalent metals. Okay, so ionic compounds involving metals that have more than one possible charge. Okay. The problem with these metals is that two compounds that are different could have the same name. And so as a result, we needed to put what beside the metal's name? A Roman numeral. Okay? We had to put a Roman numeral beside the name of the metal in order to tell people this is the iron, cobalt, copper, whatever, with the 2+ charge, or the 1+ charge, or the 3+ charge, so that they would know when they make the formula what charge to use, okay, and then get the right thing. All right, so just as a quick review of how that works, okay, let's look at number 5 here. So if everybody can just write down number 5 here, okay, and we'll kind of walk through what we did yesterday here. So we've got SN, which is tin. Okay, and we've got tellurium, right? Tin is the metal, tellurium is the non-metal. Okay, and we said in order to figure out what the charge on the metal would be, okay, because tin can be a 4+ or a 2+, okay, we have to look to the non-metal because there are no non-metals with more than one possible charge. So when I find tellurium, okay, it's right here, it's in group 16. All of the non-metals in group 16 have what charge? -2. Okay? Everything in group 17 is -1. So as you move from the far right, okay, the noble gases have no charge. So they're 0. Okay? Group 17, -1. Group 16, -2. Group 15, -3. Group 14, group 14. Okay, they're a little odd. They're the +4s, -4s. Okay, they're kind of not involved in what we're doing very much. Okay, all right. So for this one here, we know that tellurium is always a -2. And there are how many telluriums in this compound? 2. So how many negative charges do I have in total here? 4. Okay, if every tellurium is -2, and there are 2 of them, 2 times -2 is -4. Okay, all ionic compounds have to have a net or overall charge of 0. Okay, so that means 4 positive charges have to come from the metal. And I've only got 1 tin atom to do that. So the charge on that 1 tin atom has to be 4. Okay, so this is tin 4, so IV. Okay, incidentally, one of the best Rockies. Okay, Dolph Lundgren, big Russian guy. That's good. If you haven't seen it, that's good. Okay, and then telluride. Okay. Tin 4 telluride. Is that ringing a bell from yesterday? Okay. There's a tiny bit of math involved in that, but it's nothing terribly complex. Okay? Now, do some of these metals have, some of these elements have weird symbols according to their name? Anybody know why? It is. In fact, they're in Latin. Okay, so anyone that has a different symbol that doesn't seem to fit with its name, its symbol comes from its Latin name. Basically it means ancient peoples were aware of those elements and named them back when Latin was a thing. Okay? Latin's not even a spoken language anymore. All right? But some of these things have those kinds of names. Okay? Tin is one of them. I can't remember what their Latin name for tin is off the top of my head. Lead is plumbum in Latin. Okay, that's why it's PB. Okay, tungsten is a big W. Okay, for wolfram. Okay, which seems like kind of a cool name to have. Okay, and Sodium is Na, I can't remember what that one stands for. Okay, there's a number of them. Potassium is a K, right? So there's a bunch of Latin names. Ferrous for iron, Fe. Okay, so cupric for copper, silver and gold, argentum and auric. Okay, things like that. They have the kind of strange symbols because they have Latin original names. Okay. Now, why do I bring that up? Because when we go the other way and I give you the name and I ask you to write the formula, please look up the symbol. Okay? People sometimes get overconfident with their periodic table and I tell them, hey, I want you to write the formula for sodium chloride, and they go, that's not sodium chloride. Okay? That's sulfur monochloride. Okay? So we got to be careful, okay, on ones like that. Okay? All right. Let's have you guys try number 6. Left my pen over here. Okay, so for number 6, what's Hg? It's mercury, or argentum, okay, in Latin. Okay, so mercury, mercury. Okay, and At is astatine, which we would change to astatide because it has to end in ide, right? And mercury has more than one possible charge. Okay, mercury can be what? A 2 and a 1, all right? So I've got to look at astatine. Okay, astatine is in group 17, so its charge is -1. All right, how many astatines are there? 2. So how many negative charges are there? 2. All right, so I've got -2 here. Okay, that means I've got to get +2 from this one mercury atom, which means this is the mercury with the 2+ charge. Mercury 2 acetate. Okay, quick review. Do I need to put Roman numerals on every metal? No. Only the ones with more than one possible charge. So that means anytime you are writing the name of an ionic compound, you need to check, okay, to see if that thing has more than one possible charge. Because you will get to a point, okay, when we're going through this unit, where you know most of the names and most of the symbols that we commonly use, and you won't always look at your periodic table, okay, because you'll have that level of confidence in that, oh yeah, I know that the symbol for iron is Fe. I don't need to look at the periodic table. You do, okay? You need to always double check. Does this one need a Roman numeral or doesn't it? All right, let's have you try those last 4 there. Okay, and we'll go over them together here in a couple minutes before we move on to the next tricky ionic thing, polyatomic ions. All right, so for our number 7 here, we've got polonium, P-O, okay, polonium, and it's with iodine, so it'll be polonium iodide. Okay, and the charges that are possible for polonium are, well, that's the longest, okay, 2 and 4. All right, so looking at this one here, we got possible charges of 2 and 4. Iodine, since it's in group 17, is always a -1, which gives me a total of 4 negative charges, which means the single polonium atom there has to have a charge of 4, so this is polonium 4 iodide. Okay, for number 8, okay, we have antimony, which is Sb. Okay, so that's over here, and it can be a 3+ or a 5+, and it is with sulfur. Sulfur is in group 16, so it is always a -2. Okay, since I have 3 sulfurs, how many negative charges do I have? 6. All right, so I've got 6 negative charges here. Okay, that means I've got to get 6 positive charges out of 2 antimony atoms. So what's the charge on each antimony atom? 3. 6 divided by 2 is 3. Okay, so this is a +3, so we will have antimony 1, 2, 3. Okay, sulfide. Okay, questions on that one? That one's a bit trickier because you actually have to do some multiplying and dividing on that one. All right, number 9, we've got nickel, Ni, with nitrogen, so that'll be nitride. All right, nickel can be a 2 or a 3, okay? But nitrogen is in group 15, where everything has a -3 charge. All right, so -3 times 2 is -6. Okay, that means I've got to get 6 positive charges from the 3 nickel atoms that I have. So each nickel has a charge of 2. Okay, 6 divided by 3 is 2. So this is nickel 2 nitride. All right, and then our last one here, we got bismuth. Okay, and we've got oxygen, so that'll be bismuth something oxide. Okay, oxygen is in group 16, where everything is a -2. So how many negative charges do I have here? I have 10 negative charges here. All right, that means that we've got to get 10 positive charges out of that bismuth. Okay, sorry, out of those 2 bismuths. So 10 divided by 2 is 5. So this is bismuth V oxide. Okay, questions on how we do that? Okay, now, if I start to get annoying because I actually walk through and talk about every single step on every single question, that's a nice way of saying this. Deal with it, okay? That's just the way that I do things, okay, up here, because I want to walk through and always remind you of the steps, okay? If that is, if you're already way past the need for that, good for you, okay? But I'm always going to walk through and talk through the steps, okay, for everybody. All right, so before we get to molecular compounds, let's talk about another thing that could come up. What would you call this? Is it an ionic compound? It doesn't look like it, right? Because up until now, in your experience, ionic compounds contain a metal and a nonmetal. Okay? This contains a metal and 2 nonmetals. But actually, this is still a binary ionic compound. It contains a metal and a polyatomic ion. Okay? Polyatomic means many atoms. So it is still a charged set of particles. All right? Now, on the top of your periodic table, there's a box. And that box is called the table of common polyatomic ions. Okay? In there, is there an ion that is OH? Okay? Right here. What's its charge? -1. Okay, if it doesn't have a number beside it, just a dash, it's negative. If it has just a positive beside it with no number, it's +1. Okay, so hydroxide has a charge of -1, and that's what this is. Okay, so this stuff would be sodium hydroxide. Okay? We still follow the naming rules, except, believe it or not, they're actually a little bit easier. I don't have to change any of the names in that table. Okay? If I have an ionic compound and it's got one of those things in it, I just write the name exactly as it appears in that table. Okay? I don't have to change its ending to "ide" if it doesn't already end that way. Okay? I just write the name as it appears in there. All right, so tell me then what this one would be. Okay, should we still follow the ionic naming rules? Okay, so what's Mg? Magnesium. Okay, so I write magnesium. I still follow those same rules. I write the name of the metal, and then I write the name of the nonmetal. Just this time, the nonmetal is a polyatomic ion. Right? In this case, NO3 is nitrate. Okay, so this is magnesium nitrate. Why does it have brackets around it with a 2 outside of the brackets? Because that was probably confusing. You were probably looking for brackets and a 2 up on the table of polyatomic ions. Yeah, there's 2 of these. Okay, there's 2 nitrate ions in this compound. Right? So if we're thinking back to like the dropping and swapping that you learned last year, okay, if I had magnesium nitrate, I would write magnesium and its charge, 2+, and nitrate, NO3, and its charge, -1. And then I would drop and swap those 2 charges, yes? Okay, so I would drop the 1 over here, but we don't write 1s, so I would write nothing there. Okay, and then I would drop this 2 over here. But do I want to leave it like that? Because if I leave it like that, how many nitrogens are there? There's 32 oxygens. How many nitrogens are there? Just 1. Okay, but if I do this, that now says there are 2 nitrate ions, which is what I want. Okay, I don't want 1 nitrogen and 32 oxygens, so I have to put brackets around it, kind of like in math, order of operations. I want to enclose this stuff in brackets and say everything inside this brackets is multiplied by 2. Okay, that sort of makes sense? So that's why the brackets come into play. All right, let's try another one here. Let's try... Okay, what's H stand for? Hydrogen. Is hydrogen acting as a metal in this one? How do I know that? Well, it's listed first, okay? Anything listed first, okay, if hydrogen is listed first, sorry, it's acting as a metal. All right, so this is hydrogen. What's SO4? Sulfate, right? And I don't want to change the ending of that, okay? I don't want to change it to I because then it would be sulfide, and I almost wrote that because that's what I said, okay? Hydrogen sulfate, okay, would be the name of that stuff. Okay, incidentally, that is a nasty acid, okay? Ionic compounds with hydrogen acting as the metal are all acids, okay, and can be very dangerous. All right, let's try another one here. Let's try... And I'm going to put another one up here as well, guys. Okay, so let's look at the first one there. So what does Ca stand for? Calcium, right? So I follow my ionic naming rules. I write the metal first. Okay, and IO3 is iodate. Yeah. okay? Just calcium iodate, okay? We don't put any prefixes on there. It doesn't matter that there's two of them, okay? Just calcium iodate. All right, what's Li? Lithium. I got people mouthing the words, guys. Be confident. You're right. Okay, you can't go wrong here. Okay, lithium, and then what's CO3? Carbonate. Right. So this is just going to be lithium carbonate. Okay, those making sense? They're actually, I mean, they sound like they'd be really hard, polyatomic ions, but all we have to do is figure out what the name is and write it down. Okay, they're a little trickier when we have to do the drop and swap, and when we have to put brackets in or something like that. Okay, but writing the names is pretty straightforward. Just find it on there and write the name. Okay, you don't even have to change it to I, so that makes them nice. All right, any questions on the ionic stuff? Okay, so you learned two new things about naming ionic compounds. You learned how to do the Roman numerals for multivalent metals, and now you know about the polyatomic ions. Okay, now you basically know everything there is to know about naming ionic compounds. All right, so what we're going to do is move on now to molecular compounds, which you're not going to learn anything new about. All right, molecular compounds are going to be the same as what you learned last year. Okay, you won't learn anything new about molecular compounds till you get to Chem 20 and you take organic chemistry and you start learning about alkanes and alkynes and alkenes and all their weird naming rules, okay, that I barely remember. All right, so molecular compounds. Okay, so molecular compounds are two non-metals bonded together. Okay, so that's the first difference from ionic compounds. Instead of a metal and a non-metal, it's two non-metals. Okay, the other difference is a pretty fundamental difference. Ionic compounds involve the trading of electrons. Okay, the metal gives them away, the non-metal takes them. There's no commitment there. They don't want to stay together after they've got their electrons or gotten rid of their electrons. The bonds are very weak. Molecular bonds, or what we call covalent bonds, covalent meaning sharing electrons, shares electrons. Okay, the only way for a molecular compound, for the atoms or elements within it to be happy, is to have their outer shell full, just like in ionic compounds. But molecular compounds go about it by sharing the electrons. Okay, so once these two things are together, they cannot leave each other. Or their outer shell won't be full, and their life won't be complete, and they'll be sad. Okay, so these are very, very strong bonds that hold the two elements or atoms together. Okay? All right, so if we're looking at a water molecule is both a good and a bad example of a covalent bond. Okay, so in a water molecule, you've got one oxygen atom, and because oxygen is in group 16, it needs two more electrons. Okay, its charge is -2, it needs two more electrons. Okay, when it forms water, that requires two hydrogens because each hydrogen is in need of one more electron, okay, to fill its outer shell. So when water forms, what you've got is hydrogen. So this will be hydrogen's electron here. This will be oxygen's. This will be hydrogen's electron. This will be oxygen's. Okay, now hydrogen's got its outer shell full. Okay, both of them. They've got two electrons in that first shell, so they're happy. Oxygen's got its outer shell full. It's got 8 in it. It's happy. Okay, and they stick together. Everybody with me there? Okay, now I said that's the good example part of water being a covalent bond. The bad example of that is it's actually a special type of covalent bond that we'll talk about later on in the unit called a polar covalent bond. This is not a healthy relationship. Okay, if we're making an analogy here. Okay, in a polar covalent bond, one atom shares the electrons more than the other. Okay, in this case, oxygen holds onto the electrons more tightly than hydrogen does. And so the electrons actually spend more time near oxygen than they do hydrogen. Okay, and that actually results in one end of the particle being negatively charged and one end of the particle being positively charged. Okay, so this is like, when you have your friend over and you order a pizza and they eat 5 out of the 8 slices. Okay, they didn't share it very equally, and you're sour because you wanted 4 slices and your buddy ate 5 of them. Okay, that's kind of what a polar covalent bond is like. The electrons are shared, they're not traded. Okay, all right. So the naming rules, okay, for molecular compounds are as follows. Write the name of the first nonmetal exactly as it appears on the periodic table. Write the name of the second nonmetal, changing its ending to "ide," just like you do for any other compound. Okay, so second element ends in "ide." And then you apply prefixes. Okay, molecular compounds need prefixes because they're sharing electrons, not trading them. There's any number of ways that any two atoms could combine with each other and be happy. Okay, so because they're sharing electrons, you're never going to balance the charges like you do in an ionic compound, because all nonmetals are negative. Okay, so you're never going to make those charges balance out. You keep adding negatives, you just keep getting more and more negative. Okay, it's like 2 wrongs don't make a right, but 3 do. Okay, all right. So when we're naming these, if we have this example here, okay, CS2 would be carbon disulfide. Okay, I write the name of the first nonmetal exactly like it appeared on the periodic table. Okay, and then I write the second one ending in "ide," and I put in any prefixes that are appropriate. Okay, there's a 2 on the sulfur. Prefix for 2 is di. Okay, why didn't I put a prefix on carbon? What's the prefix for 1? Mono. Okay, but because chemists have to feel superior to everyone else, okay, they have rules. Okay, for some reason, the first element doesn't get a mono. It gets everything else, but you never put mono on the first one because, well, reasons. Okay, but you never put mono on the first one. You put mono on the second one, but not on the first one. Okay, so that we have to have something to remember. Okay. All right, for our second one here, okay, this name is actually wrong. What was missing from it before I scratched it out? Mono on the oxygen. Okay, so this would be dinitrogen monoxide. Okay, you can say monooxide, but we generally just write monoxide. Okay, for that. All right, so the "ide" suffix, like we said, is only added to the last one. Okay. Let's write the prefixes. These you can put on your periodic table if you so desire. Okay? So 1 is mono. Okay? 2 is di. 3 is tri. From here on, they follow your geometry. Okay? So they follow the same things as your shapes. Okay? So 4 is tetra. Okay? 5 is penta. Okay? 6 is hexa. All right, now 7. Okay, lots of, somewhere along the way, someone taught septa, okay? And that, I find that that happens more with people who took science in French. But just so you know, septa will trigger Mr. Real, okay? Who is a Chem 2030 teacher. So I always teach hepta, because Mr. Real is a grumpy old man. Okay, just like me, I'm a grumpy old man too. Okay, but if he gets triggered, there will be loud noises everywhere, and it'll be bad. So, okay, hepta is the prefix you want to use. Okay, for 7 in his presence. Okay, number 8, octa. By the way, I'll ask Mr. Real what it looks like under the bus I just threw him under. Okay, later on, but okay. 9 is nona, and 10 is deca. Okay, you won't have to know past 10 for our purposes. Okay, now at this point we do have to address a couple of things that come up, okay, and those are the molecular elements. Okay, there are some molecular elements, that is, elements whose atoms bond to themselves to make a molecule. Okay, that's still an element even though it's a molecule. That's why we call them the molecular elements. Okay, oxygen is an example of one of the molecular elements. Oxygen always comes as a pair, O2, right? That's the gas we breathe in, O2. Okay, so it's a molecular element, okay, as is hydrogen, as is nitrogen, as is chlorine. Okay, basically, the molecular elements, okay, are in this part of the periodic table. They make kind of a 7 here, okay? They go across to here and down, right? Now, you do have to memorize them, okay? If you write them on your periodic table and then you get your fresh periodic table on your final exam, it's going to be bad. So you're going to have to memorize these, okay? But they are nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and astatine. So this 7 here, these all come as a 2. Okay, so N2, O2, F2, Cl2, Br2, I2, At2. Okay? The other one that's a 2, hydrogen. It's the only outlier. Okay? It's the one that ends up way over here all by itself. Okay? H2. And then there are the big ones. Phosphorus and sulfur. Okay? Phosphorus comes as a 4, P4 when it's by itself. And sulfur as an octet, 8. Okay? Sulfur comes as S8 when it's by itself. Okay? So those are the molecular elements, not to be confused with molecular compounds. Okay? That's why we're bringing it up now. Molecular element is a molecule, but it's only made of one element. Okay? A molecular compound is a molecule made of 2 or more elements. Okay, everyone follow the difference? Okay. All right, let's try a couple of examples here. Okay. Come on. Okay, I want you guys to write the names for those 4 molecular compounds. I'll give you a couple minutes. Okay, so let's have a look at these ones here. All right, so our first one, what's N? Nitrogen, okay? And according to the rules, I write the first one, the first element, as it appears on the periodic table, okay? And then my second element is iodine, so that's going to be iodide, but what prefix do I need to put on it? Tri. There's 3. All right, now, this one's a little bit weird. I suppose technically, according to English language rules, you would need to put a hyphen there. But I wouldn't mark it wrong because I'm not English. Okay? I don't teach English, so it should probably have a hyphen. It looks better with a hyphen. Okay? But it wouldn't be wrong if you didn't do that. All right, number 2, what's the first element? Carbon, okay? And carbon is a non-metal, okay? But I write it as it appears on the periodic table, and then it's with iodine. What's the prefix for 4? Tetra. So this would be carbon, tetra, iodide. Okay, again, that's probably one that should have a hyphen in it. Okay. Okay, and then number 3, okay, I've got, what's N? Nitrogen. What prefix does it need? Di. Okay. Dinitrogen, okay, and then what prefix would I put in front of this? Trioxide. Okay, so dinitrogen trioxide, and then for number 4, do I need a prefix on the tellurium? Okay. All right, what prefix do I put on the astatine? Di. Okay, tellurium diastatide. Okay, is that ringing a bell? Okay, nothing new. This is exactly what you did in Science 9. Okay, there's nothing to add to your molecular ones. All right, try up to number 10 there, okay, for a little bit of practice, and then I'm going to really throw a monkey wrench into it after I give you a little break. Okay, so after this one, you'll get a quick in-room break here. But I'm going to throw a list at you that's got some ionic, some molecular, some that need Roman numerals, some that have polyatomic ions, and you're going to have to figure out which rules you need to apply. All right, so for number 5, I've got 2 phosphorus, so I'll have to go diphosphorus. Okay, and then I've got 3 sulfurs, so trisulfide. Okay, if you got questions about these as I go through them, don't be afraid to ask. Okay, for number 6, I've only got 1 oxygen, so that doesn't need a prefix. Oxygen, and then there's 1 sulfur, so that would be monosulfide. Okay, and then for number 7, I've got 3 silicones, so that would be trisilicon. Okay, and then tetraphosphorus. Okay, and then for number 8, I've only got 1 sulfur, so I don't need a prefix there. Sulfur, and then I've got 2 chlorines, so dichloride. Whoop, what's wrong with this one?
You forgot the ide thing.
Right, I forgot to end it in ide. Okay, and then for number 9, okay, only 1 silicone, so silicone, okay, tetrahydride. How do I know that hydrogen is acting as a non-metal in this one? Right, it's listed second. It's only a metal if it's listed first. Okay, silicone tetrahydride. And then for this one here, we would have tetraboron tricarbide. Okay, questions on any of those? All right, what do you suppose Thursday's quiz will be on? Yeah, exactly. All right, I'm going to give you a quick 2-minute break here before I throw another list at you so you can answer any snaps that have been burning away on your phone there. Okay, and then we'll talk about the next list. Okay, guys, so I'm going to put 4 up here. Okay, and there's a mix now. Okay, some of these are ionic. Some of these are molecular. Some of them need Roman numerals. Some of them don't. Okay? This is the more realistic kind of thing that you would get here. Okay, is, all right, I have to first figure out, is that ionic or is it molecular? If it's ionic, does it need Roman numerals? Does it have a polyatomic ion? Okay, this is where you have to do that identification. That's trickier than if I just give you a list and tell you they're all molecular and off you go. Okay, so give these 4 a try here. I'll give you a couple minutes, then we'll walk through them. All right, let's have a look at these 4 here. So number 1, is that ionic or molecular? It's ionic. Lithium is a metal. Okay, if it starts with a metal, it's ionic. Okay, so I'm going to follow the ionic naming rules. I'm going to write the name of the metal, lithium, and then the name of the nonmetal, ending in ide. Okay, that is simply lithium chloride. Okay, don't need a Roman numeral on that one because lithium is only ever a +1. Okay. All right, for number 2, I've got chromium. It's an ionic compound because chromium is a metal. Okay, and what else do I need to know about chromium? What its charge is, because it's got more than 1 possible charge. It could be, I think, a 2 or a 3, right? 3 or a 2, yeah. Okay, so chromium, and it's going to be chromium fluoride. I just have to figure out what Roman numeral is going to go after chromium, right? So to do that, I look at my fluorine. Fluorine's always a -1. There are 3 of them, so I've got to get 3 positives out of 1 chromium. That makes that the chromium with the 3+ charge. So chromium 3 fluoride. That's the kind of thing that's easy to forget to do. Okay, that's why I'm throwing you a list that's got some of every kind in it. All right, for number 3, we've got phosphorus. Is this an ionic or molecular compound? Molecular, right? It's got 2 nonmetals. Phosphorus and bromine are both nonmetals. Do I need a prefix on phosphorus? Okay. All right, phosphorus, and it's with bromine. What prefix goes on the bromine? Tri. Right, and it's going to be tribromide. Okay. And then for number 4, ionic or molecular? Ionic. Zinc is a metal. Okay, does zinc need a Roman numeral? No, it only has a +2 charge. Okay, so zinc, iodide. Okay, for some reason, zinc is one that people feel like they need a Roman numeral on. I always see mistakenly people putting a Roman numeral on zinc. I don't know what it is about it. Okay, it doesn't need one. It only has a +2 charge. All right, tomorrow we're going to go the other way. Okay, we're going to go from name to formula. All right, because all we've been doing is here's the formula, write the name. Tomorrow we're going to look at the rules for going from name to formula. All right, good work today, guys. So we'll start out with that tomorrow, and then Thursday you'll have quiz again to start a class, but I will post that quiz tomorrow after school.